Hi, my name is Maulik Aglani and welcome to my video on what an ALU is. I'll be going over the function of the ALU and my journey on building the ALU circuit. What is an ALU? An ALU is short for Arithmetic Logic Unit. It is a digital circuit that performs all arithmetic computations such as addition, subtraction, multiplication, and division. It also performs logic comparisons such as mostly but not limited to and, or, and not. The ALU is the fundamental building block of the central processing unit, also known as the CPU, inside a computer system. All information used and stored by digital circuits, in this case the ALU, is in binary numbers, which are 0 for logic low and 1 for logic high. Inputs and outputs flow through electrical paths called buses. Now, in the ALU circuit that was to be built for the project, there are two input data buses, one 3-bit data bus A and the other one is a 3-bit data bus B. Also in the ALU there are places called registers which store information. I have two registers in my circuit, one 3-bit register for one of the input data buses and one 4-bit register for the outputs, which is also acting as a register for the input data bus A. Now the final result after the execution of any operation has to be stored somewhere. This data, this information is stored in a place called the accumulator, which is the same as the register for the outputs. The flow of bits and operations to be carried out is controlled by gated circuits. Specific arrangement of these gated circuits means that specific operations can be performed by the ALU. In the circuit that was to be built for the project, we were using one half adder and two full adders. This allows the particular ALU circuit to perform addition. Let's move on to the specifics of my ALU circuit. The circuit is being used as a memory circuit which takes use of the commercial D flip-flop circuit, which is a synchronous sequential circuit. These D flip-flops have a positively edged triggered clock pulse, which means that the output in the registers only changes the instant moment the clock changes to a logic high. In this case, the clock is positively edge triggered but has been inversed by the AND gates, which means that the output in the register only changes the moment the clock receives a logic low, a 0. The section of the circuit that is doing the adding is the combinational circuit. The gates are arranged in adders so that they can add inputs A and inputs B together. Now let's take a look at the circuit itself. Moving on, I would like to reflect upon my process of building the circuit. I strongly believe that I could have done much better and that this project was not my strongest performance by far. I think that the reasoning behind the poor performance by me was due to time management problems. I had followed the Gantt chart timeline up until the building section. I fell behind after missing the first build day and not getting much done during the long weekend, because I had misjudged the time that would be required for me to build and test the circuit properly. After falling behind the first build day, the situation got worse by each day as I was trying to catch up the missing days. I could improve by managing my time wisely and putting a little extra time into circuit projects, as they should have at least 1 or 2 days kept aside for testing and troubleshooting. This concludes my video about the ALU circuit. Thank you for watching. And
created using Powtoon.